Hey folks, welcome back to the Metal Mill 52 workshop. My name is Bill. This is my shop. This is my Allen Mogul locomotive without the cab on. The cab roof is there sitting on my workmate workbench that I've been using that as my little work table for a lot of the different projects, finishing up the corn and all. This week, since I haven't received the sewing machine motor for my spindle grinder, I went ahead and I repaired a couple of leaky fittings that I had on this side of the locomotive. So if you'll stay tuned for the next 20 minutes or so, I'll show you how I did that. I've got the air compressor hooked up and we have about, let's see, about 20 psi or so. I don't have my glasses on, but I've got it in forward on the Johnson bar. I thought I'd run it a little bit. And we can blow the whistle. Not much steam or air pressure left, as it were. So we'll close out there. Thanks again to all the new subscribers. If you're interested and have a question, please just ask. If you like the content and enjoy it, please at least give me a thumbs up. That way I know that people are paying attention to what I'm doing here. So I enjoy it, and I hope you do too. Have a great week, everybody. Well, during this week, I decided to check on a few more fittings on the locomotive, and I realized that I actually had a couple of leaks. This is the supply line from the whistle valve down to the whistle. So, long story short, I've disassembled that completely, and then I resoldered the connections on this adapter that goes from the valve itself to the line. I resoldered both sides of that. Got it cleaned up and ready to reinstall. It's passed the blow test, so I think it's going to be okay. I also cleaned up the threads, and I'm going to use some Never Seize stuff, anti-seize lubricant on these threads, because all these threads do, they hold this cone into a nozzle shape over there that's just a press tension fit. And same thing for here, that's what that joint is, and a similar one here on the whistle itself. So that will get reassembled. I'm going to use some of the high temperature Permatex like I did over here. I'll use that on these pipe threads here, so that'll get reassembled. What I've just finished doing, the line that comes from the, sorry about the camera work there, the quick start valve that will supply steam to the injector down here, I found a little leak, not in the valve, but in the fitting, similar to like right here, except on the other line. So let me kind of spin around here, and I've carefully repaired it. I'll take this apart in a second. It's cooling right now, but I just finished resoldering this joint right here. What you see all wrapped up is the cone and nut, which I had to previously solder because it's kind of a tight fit, but I put a wet rag all around it and some tin foil to protect that joint. And then similar deal here, a wet rag and tin foil to protect all the other soldered joints. So I'll take that apart. It should be cool now. Take that apart, examine it, and get it ready for replacement. Okay, I've just tightened this one up all the way. I'm going to briefly go over the process now. Just to be on the safe side, I completely tightened this union joint before I assembled anything else, and I did use some anti-seize on that as well, this copper anti-seize product. So in case I ever have to take that apart, it'll be easier to do, hopefully. Now this one is not fully tightened yet because I wanted to make sure that I have plenty of flexibility for when I tighten up the connection to the quick start valve up there, and it's not fully tightened down here on the injector yet either. So it's just everything's screwed on finger tight so that I don't have run any risk of cross threading. But my objective here, because there's some odds and ends and bends here, I'm going to coat the threads here with the anti-seize and using the little paintbrush. I'll carefully coat it so that none can get inside the opening there, and then I'll tighten that. I'll start to tighten that and progressively tighten up the rest of them. Also, before I did any of this stuff on here, I put the Permatex high temperature stuff on the pipe threads that go into the actual whistle valve and tightened that up first. And basically, in order to get the alignment just perfect, I kind of held this tube like this way and moved the tube arrangement in so that cone lined up perfectly with the nut, and then started it on very gently, getting it threaded, and then eventually tightened it up with the wrench. Okay, folks, something I forgot to mention before. Obviously I took the cab off, so you get to see what the locomotive looks like without the cab on. Really glad I did it because it made it a lot easier to get to those pipes. And if you're wondering why I ran them that way, I did it on purpose just for aesthetics, really, because that's kind of the roof line of the cab, basically. So it looks pretty clean when the cab is on. So I've reassembled everything, tightened it all up. Hopefully I did a good job. If not, I'll have to take it apart and do it over again. But we'll test it. I'm going to let it dry, let the high temperature stuff dry overnight, and we'll take it, charge up the air compressor and check it tomorrow night. Also, you can see the effect of the wax. I do wax this is just Rust-Oleum paint on the boiler wrapper, carefully applied, several coats of primer and top coat gloss black Rust-Oleum. But I put some automobile wax on it and covered that on the brass boiler bands too. There's no lacquer on these things, it's just shined with Brasso and then waxed. So it's held up pretty well. So we'll clean that up, test it tomorrow, see how it works. Hopefully I've cleared all the leaks, and we will bolt the cab back on. I'll shoot some video of it running like this with the cab off, so you can kind of see some of the moving parts. To me, it's really interesting. Can't wait to see if the whistle sounds like it should tomorrow. Alright folks, well here we are, got it about 90 psi on the using the air compressor, and you can hear how quiet it is. I think I have a couple small places I need to attend to, but the major ones that I was worried about that I'd taken apart, looks like I did a good job. I had soapy water on these. I just had to snug these fittings up a little bit, but it looks like the pipes themselves are airtight, and the whistle sounds a heck of a lot better. If you remember any of the previous videos, that sounded like a kind of an anemic whistle. Now it's sounding really good. Really excited about that. So yeah, I think I've cured probably 99-95% of the leaks anyway. Probably a few things to snug up. I can feel a little draft on a couple of these things. So anyway, overall I'm pleased because I've got the new valve installed here for the injector, and you can hear it. Sounds like it's very effective. Time will tell once we actually get the water supply hooked up to it, but it sounds good. And the pipes are all solid and no excessive leaking there, so pretty excited. Let's go ahead and run it. I've got the cab off, as I noted before, so you can see the Johnson bar really good. So that's in full forward. This was a casting that I machined, and then I made all this stuff by hand, basically on the mill and the lathe and file. So that's the cool thing about these projects. You will end up making a lot of stuff yourself. A little light on the locomotive, and so we've got it in forward. Got about 80 psi now. Runs like a jackrabbit. This is neutral on the Johnson bar. Still forward a little bit, huh? Anyway, and that's full reverse. It'll run the pressure down pretty quick. Let's hear what the whistle doesn't sound like much. Here's the blowdown valve, is right here. I'll open the other one. That helps get any moisture out of the boiler. So that's cool. I think I'll let it sit, and what would be the most effective is to go ahead and run it on steam and see how it is when everything's hot. Probably certain of these brass things would probably loosen up a little bit with the heat, so I'd have to snug them up. So I'll definitely bring a wrench when I take it out to the track again, but pretty excited about the improvement that this week has made. It's Thursday night. I still haven't received my little sewing machine motor to finish my grinding project, so this may suffice for this week's shop work so far anyway. I had a little air left in the compressor, so I hooked it back up again. So what are we on? About 60 psi there. And I haven't shown this before, but I wanted to. These are, speaking of making things, with the Allen casting set, you do get these cool brakes, and they're vacuum brake or steam operated brakes. So if you could see what I'm doing, I'm actuating this lever here. Now I did not build this valve. This is actually a loco parts piece right here, but I move it forward, and that sends what will be steam when it's running, or compressed air in this case now, through a pipe down to these cylinders, and they're crossed, so that when the arm goes down, it pulls back and it actuates the brakes. So here we go. Let me back out a little bit so you can see the whole thing. So moving the lever forward, see the arm go down, and that actuates the brakes. Pretty cool. I did machine the brake cylinders myself, and the tops and bottoms, those are just castings. And it's a stainless steel actuating rod, and there's a piston inside there, just like a locomotive valve, or locomotive cylinder basically, which makes good practice when you're building one of these things. Practice making a cylinder to fit. There we go, that's this side. You can see it there. Go down. Cool. How much PSI? We got 60 PSI. Let's run it halfway forward on the Johnson bar. Crack the throttle a little bit. Pulling on the whistle. That sounds pretty good down at about 40 PSI. Pretty excited about that. Alright, let's close the throttle. Move the Johnson bar like halfway reverse. That sounds cool, doesn't it? You can hear the little cylinder valves, they're open, the cylinder cocks. Alright, let's put it full forward again. You can hear the stack talk is what they call that, the sound of the cylinders. That's exciting. It's even more exciting when you're out on the track. Look at that. We're down to like 10 PSI and it's running smooth and sounding good. That's so cool. Not even enough pressure to make the whistle go. Alright. Let the blow down. I'll have to put a headphone user warning on this video. I found the culprit for the little extra breeze that I was feeling. It was actually the vent tube from the top of the boiler here to the top of the water sight gauge. And what I've done, I've taken the pieces apart and cleaned them off, but as you can see here, this is a 1/16 pipe thread here that I'm tapping with my finger, and then this is an ordinary model engineering thread over here, probably 32 TPI. So I've made this little adapter myself years ago, excuse me, and it goes into this tube here that I also made. There's one of the little miniature cones and a nut that goes onto this threaded portion here. And this part, sorry, little cone fits in the back here, and tightens up there. So what I'm going to do in a minute here, I won't videotape this, but I'm going to use some of this high temperature thread sealant on the pipe thread portion and tighten that up, and then I can use some of the anti-seize on the brass on brass fine thread connections here. So hopefully that'll take care of that leak that I found. And if it doesn't, I mean, like I said, I'll probably have to heat things up and tighten it all, but the high temperature sealant should work for the pipe thread anyway. I may have to snug stuff up after that.